All right, so today we're going to be picking up where we left off. Now, if you look up here, guys, this is not a multiple part question. This is a multiple choice question. So one of those answers should be correct. So here we're interpreting your p-value. Go ahead and read through that. Talk with each other if you don't quite know which the answer is. Okay. Remember what our interpretation of a p-value was? P-value is the probability of getting a sample as extreme or more than ours if the null hypothesis were true. So I want to kind of think about this question. What would the null hypothesis be for this problem? No change? Yeah. The null hypothesis is always that there is no change. And no change is going to be, if I interpret this, because these guys have adds and stuff like that, that's just basically saying it was as if the adds weren't even there, right? Adds, no difference. So understanding that the p-value is 0.22, what is going to be your interpretation here? What do you think? Anybody want to give it a shot? Give you a hint. It is going to be a letter, A through D. How about that? Can you eliminate anything? You're like, I know that one is not right. All right, let's go through it one at a time. There's a 22% chance the adds worked. That 22, that's the p-value. Does the p-value talk about something changing? If I were to interpret my p-value is 0.22, right? I would literally put it in here. The probability of getting a sample as extreme as ours, if the adds actually did not change the governor's approval rating, just through random sampling, is 22%. Got it? P-value. The probability of getting a sample, there's a 22% chance of getting a sample as extreme as ours, or more so, if the adds really had no change just through random sampling variability. Which one is that? D. Look at what D has that the others don't. Sampling variability, that's just by chance. Results like these, if there's really no change. Do you see what I'm talking about here? It has nothing to do with the fact 22% they worked, or the flip side 78% chance that they worked, has nothing to do with that. Chance that it's correct has nothing to do with that. Okay, on the quiz that you guys took yesterday, the most missed question had to deal with interpreting your interval. You guys just have to memorize these. If it doesn't look like that, it's not the answer. Okay, so the answer here was D. Now, when we're talking about p-values and their whole purpose, like on this one, my p-value here we said was 22%, or 0.22. That means there's a 22% chance of actually getting our results if the null was true, if there was no change. Is 22% something that you're going to say, oh my gosh, that's clear evidence that there is a change? Would you be surprised at a 22%? What percentages typically start surprising us? How many standard deviations away? 2 standard deviations away. 2 standard deviations knocks off what percent? What's within 2 standard deviations? 95. So what's on the outside of that? Nope, 95 is in the middle. What's on the outside? 2.5 on each one, or 5 total. So that is definitely not even close to either 2.5 or 5%. That thing that I'm talking about, that 5%, that is what we call our alpha level. That's basically our level of doubt that we're going to set. It's going to be like, okay, this has to have this random chance of occurring in order for me to kind of think that things are now different. Now, normally, the standard alpha that you're going to use, if nothing else is said in the entire problem, if they just say test it, you're typically going to use a 0.05. There's a lot of criticism right now in statistics about the fact that people kind of always go to 0.05. Really, if you're going to be doing statistics in the real world, you want to kind of think about that number, because it's about a balance of, is it going to be accurate? Is it going to be effective? What are the dangers? And we'll talk about that when we get to errors. And basically, we're saying that your p-value is if the data is consistent with the null, whether or not it is, whether it's an unusual sample or not, anything less than 5%, we start looking at an unusual sample. And if the data is consistent with the null, it's not going to be unusual. Your p-value will be bigger than A, and our conclusion is going to be that we will retain the null. Or the words that I usually use, fail to reject, and that's what's going to be up on the sentence with that as well. Okay. And there it is. We never, ever, ever prove anything in this class. That is not our jobs. Our jobs are to see if whether or not we can even start looking in that direction. Let somebody else make the definitive decision. We either say we have evidence to support a claim or we don't. So for this guy, I don't have anything unusual going on, so I'm just not going to reject the null hypothesis. If the data isn't consistent, if there's something funky going on, it doesn't quite look like what we originally claimed to be true, then that means it's not going to be likely to occur by natural sampling variability. You would not expect that on your way home today, your hair falls out. I randomly got that. Don't know where that came from. If you walk home and your hair randomly all falls out, I probably would not assume that you are healthy and normal. I would start going, something is going on here. If you're playing a sport and all of a sudden no one touches you, but you black out and you fall down, pass out, I would no longer assume that everything is normal. I would assume that there's something funky going on here. That's what we're looking at. The data is not consistent with the null or with the fact that everything's normal. You're going to see a p-value of less than alpha. Ryan, please put the food away. Food away. And we're going to say when that occurs that we reject the null. Okay? These are going to be your two main decisions, either fail to reject or reject the null. And I'll pull that poster over here next class. But it's a nice formulaic response. If your p-value is less than alpha, you reject the null. If the p-value is greater than alpha, you fail to reject the null. And these here are the things that are important. P-value bigger than alpha, fail to reject. P-value less than alpha, reject. Maybe if you take notes, you won't fall asleep quite so easily, gentlemen. Write stuff down. Maybe that'll help you stay awake. Okay, those are the two big things. P-value, blue statement. P-value, blue statement. If you write nothing else down from that board, you're okay. That's the center of what we're talking about. But the p-value is just, what are the odds that that occurs just by chance? And if the chances are slim to none, then it probably did not occur just by chance. There's probably something else going on there. That make sense? All right, here we go. So it's a whole idea. If the defendant is innocent, if I go and I charge Eden with murder. Eden, dang. What you been up to? But obviously she didn't do it. Are they going to come around at the end of the trial and proclaim Eden to be innocent? Is that one of their choices? What will they say? Not guilty. They have choices of guilty or not guilty, right? Well, that doesn't mean that if you're not guilty, you're 100% innocent, which is sometimes a bad thing. If Eden is brought up on charges of murder, even if she is innocent, 100% innocent, that's going to follow her. Would you agree with that? Just being accused. Because being declared not guilty does not mean that you are innocent. It just means that you don't have enough to say that you're guilty. And they may be innocent, but the burden here is not on the defense to prove someone's innocent. It is on the prosecution to say that they're guilty. Okay, that's what we're talking about for a jury trial. So with that, the decisions that we have for all of our hypothesis tests, we are never going to say, accept the null. We're never going to say, keep the null hypothesis. You are either going to reject the null, you are either going to say guilty, which is reject the null, or fail to reject the null, which is just not guilty. Those are your choices. That's all you have. And sometimes they say retained. Don't use that word. It will confuse you. Okay? Use those two sentences that we had before of either reject or fail to reject. Stick with that. You will always be good. Okay? Never talk about the alternative hypothesis with that. All right. Read through this. Remember, this is all about interpreting. We'll do the math later. What do you think? What should you pull from this sentence or from this situation? What are some big things? Give me one. The p-value is 0.017. Taking all the context away. I didn't give you an alpha level, so what should you use for alpha? 0.05. P-value is 0.017. Compare those two numbers. What's true? The p-value is less than the alpha, right? P-value is less than alpha. What should you do? Reject the null. And the null hypothesis here would be what? That there is no change. So all I'd have to do here is I would say with a p-value of 0.017 being bigger than our alpha, we have enough evidence to claim that the proportion of high school seniors who own their own cars is higher than it was a decade ago. Okay, and this says it's reasonable to conclude that a greater proportion of high schoolers have cars. That 0.17, that means that there's only a 1.7 chance of seeing a car lot like ours if there really had been no change. And that's pretty rare. Would you agree that there's a 1.7% chance that this will occur? Are you going to bet on that? Probably not. It's like betting on the Redskins to win the Super Bowl. Just kidding. Or the Patriots this year winning the Super Bowl. Oh, snap. Cheaters. I don't have any strong opinions. All right. So remember seeing this problem? We told you we'd come back to it and we'd do it all sorts of different aspects. Last time what we talked about writing the null hypothesis in the alternative. We said P was a proportion of homes that had a smoke detector. So we said the null was that there was no difference. It was equal to 0.9. The alternative was that it was greater than 0.9. And in going through all of that, and we'll show you how I actually calculate this next class, I ended up getting a p-value of 0.004. Do you think that that is strong evidence that the local rate is higher than the national rate? I'm seeing some people going, the slowest nods ever. Doesn't give us an alpha. They don't give you an alpha, what do you use? 0.05. What am I comparing to that 0.05? The 267? The 0.04. I'm comparing this to my alpha. How does it compare to the alpha? It's smaller. It's less than. So if your p-value is less than alpha, do you reject or fail to reject? You reject the null. You reject the null and claim that we have evidence that the local rate is higher than the national rate. Okay? And basically what that's saying is there's only a 0.4% chance of seeing this sample just by random sampling variability. Just by coinky-dink. Okay? That's what that p-value is talking about. Okay. A little bit of backup. Go for it. Actually, write it down. Oh gosh, she's asking us to actually work. Yes. We don't have many more slides here. So before I state my hypotheses, what should I do? Right here, huh? Write what P is. What is P? Bingo. P is not the probability that your friend is psychic. We're not talking about that. We're talking about the proportion of correctly identified cards. Does that make sense? It's not about are you psychic or not. Somebody else is going to make that decision. P is a proportion of correctly identified cards. What is the null hypothesis going to be? P is equal to? Why is it 0.25? There's 4 suits. Right. One of them will be correct. So P is 0.25. Okay. P is just the probability of getting the correct suit. And so the null is that P is equal to 0.25. Now, the alternative. What would the alternative be? P is greater than 0.25 because if somebody is psychic, you would expect them not just to have a different probability, but if they're psychic, they're probably not going to get it worse. Right? They're psychic, they're probably going to get more correct. So your alternative hypothesis is greater than 0.25. Now, it is extremely important here, guys, that you understand that we are not talking for my null and alternative about someone being psychic. I'm not measuring your psychic abilities. I'm measuring your ability to correctly guess a suit. Be very careful with that. Okay? In statistics, you deal with a lot of questions dealing with discrimination or racism. We're not going to come out and say the court system is racist. We might come out and say that there is not an equal distribution of prosecutions between blacks and whites or minorities and Caucasians. Okay, we are not going to make that claim because there are other things that could be going on. Maybe your friend is better at guessing because you are sitting in front of a mirror, you big dork. And they're looking in the mirror. We're not making comments on that. Courts might not be racist. It might be biased towards those socially, economically disadvantaged. If you have the money, you can afford the lawyers. You don't have the money, you're stuck. Where does the money go? There are other things involved with that. Do you understand what this is? Huge. This is not a judgment call. This is an observation of evidence, and that is it. Okay. I don't know the exact results. I know they did better. And I had a p-value of 0.014. What would you conclude? Don't all answer at once. Or, yeah? You would reject the null hypothesis. Why? Bingo. Simple. Since the p-value is less than 0.05, we would reject the null hypothesis. There is evidence that your friend's claim of guessing the correct suit is greater than 25%. Do not go to those psychic powers, though. They could just be a cheater, pumpkin eater. Have the order of all the cards memorized because they're cool like that. I don't know. What if my p-value had been 0.245? Failed to reject the null. Okay, I don't know what's going on right now, but I'm getting a lot of extremely blank stares, people falling asleep. You're responsible for this material, so maybe be a little bit more engaged, a little bit more part of this, rather than just one person answering. So again, p-value greater than 0.05, we fail to reject. We don't have enough evidence. And this is going to be our formulaic response. I'll put this up, I'll pull this over here next class for you guys to copy down. But it's always going to follow that idea. All right, this is what your mathematical work will be for a problem. Okay? This is in your notes if anybody's actually looking at their notes. It says there, we already talked about this first piece. We already said that the appear to be 20% orange M&Ms. So we said P was the proportion of M&Ms that were orange. My null was that P is equal to 20%. My alternative, P is not equal to 20 or 0.2. This is going to be the numerical math that you'll have to show. Look at what this is. Just kind of take this in for a second. What is this calculating? Z-score. It's the statistic. Observed minus expected over standard deviation. That was your Z-score formula, right? We did X bar minus mu over sigma. It's just that when we're talking about proportions, it's P hat minus P, and that's the formula for standard deviation. That's them actually calculating it. That's the Z-score that they actually got. And this comes from saying, if that's my Z-score, the probability that it is further away from that is going to be 0.44. That's my p-value. Does this contradict the company's 20% claim? No, why not? It's greater than 0.5. What is greater than 0.5? The p-value, 0.44, but that's not greater than 0.5. 0.05. Okay? Since 0.44 is greater than 0.05, we fail to reject. We do not have enough evidence to say that Mars's claim is wrong. That the proportion of M&Ms is different than the advertised 20%. Okay? So, in a nutshell, summarizing everything that we've talked about, because next class we're going to do the math for this. You're going to start by putting your P in context. Is this a big surprise for you? You're going to determine your null. Wait a minute, we've seen this before. Just in case you guys aren't like putting 2 and 2 together. You should have all of this written down already. Determine your null hypothesis. Your null, HO, is always that P equals a number. Your alternative is always that P, some other symbol, that same number. And you pull that from the question. Find your p-value. And again, it's a very simple calculation. I just showed you really quickly how to do it. It's going to be super easy on your calculator. Find the probability, getting our sample, if the null hypothesis was true. Compare it to alpha, and you are going to make your conclusions. Okay? That's it. That's all I didn't get to last class. Your homework is, I do want you reading chapter 19. Okay, it's very important that you read it. They do a really good job of going a little bit more into it, especially since half of you guys are in a zombified state right now. Okay? There is a very short video that I want you guys to watch. And it is specifically just so you write the stuff down. Okay? And you have the My Math Lab do not next class. Do the night before the class after that. Okay? Any questions? Hang on. So today is Thursday. Next class is Friday. No school Monday, so your next class will be Wednesday. So it will be due to Tuesday night. Tuesday night. So before Wednesday. Yes. Okay?